Okay, it's great to be here. My name's Chuck Gill, Charles Gill, whatever. I have a call sign, but it's probably not appropriate here. I'd like to talk today about Vorbeck materials and more importantly about graphene. You know, what do we think the future of graphene is and how it can be important to both UAS and the space communities. And anybody here from Grand Forks Air Force Base? Curiosity? I won't do my shout out. My old bomb squadron's there, so I was very proud of the fact my bomb squadron's at Grand Forks right now. So Vorbeck was founded in 2006, and we have deep roots in research with both Princeton and the University of North Dakota. We're staging large-scale production in Grand Forks as we speak at this facility in Grand Forks. And our core capability is advanced graphene applications. We have over 100 patents, a lot of them related to graphene itself. And graphene, if you're not aware, was the topic of the 2010 Nobel Prize. So it's a relatively new thing, you know, hot new material, and the company's trying to figure out what we can do with it. Our primary customers are Department of War and first responders, and a portion of our staff is cleared to do work at the TSSCI level. What you see there is what graphene is. It's a single layer of carbon. What's unique about that? It's two-dimensional, it's not three-dimensional. And what that means is there's each atom has a free conduction electron, and there's no energy gap between the conduction band and the valence band. That means that the electron's free. And another interesting thing about it is a really smart guy named Dirac, early in the 20th century, predicted that electrons in this configuration would act like massless particles. So what you have is an extremely light material with massless electrons that can react to an incoming RF wave, or if it's stimulated with a current, they can radiate an RF wave. And that's where we think graphene is applicable to some of the things we'll talk about here in the briefing. It has exceptional conductivity at low weight and low cost. It's just carbon. And if it's properly processed, and that's the foot stop for Vorbeck, when it's properly processed, there's really little heat effect on its conductivity as predicted by Dirac. It can be discrete. It can be woven, as you see here, into fabrics. It can be folded. It can be manipulated, and we have some on our booth if you want to come out and play with it. We'd like to use it for a variety of warfighter applications, and also for first responders, and especially UAS, which I'll be talking about more here in a minute. We're good at antennas, and we're getting better at arrays. So not only can we make an antenna, but we can make a lightweight array of it as well, for both sensor systems and UAS guidance, navigation, and control. And the one thing I really want to foot stomp, given all the discussion this morning about counter UAS, is that we are a counter UAS. Mentioned that I had some experience in the intelligence community, and one thing in the R&D programs I supported in the intelligence community was, well, if we can do it, you know, somebody else can probably do it. So this is kind of an awareness of what might be possible with some of the counter UAS initiatives out there. So our 4-inch shielding can be coated to a variety of fabrics that I've listed down here at the bottom. You know, Kapton, carbon fiber epoxy components, FR4, PET, and we have a PET example at our booth. And a 3x4 layer of it, you know, you can put it over your power control module, you can put it over your GNC card, will only weigh about 0.2 ounces. And if you're really paranoid about a wideband attack, everything from UHF to K-band signals attacking your UAV, you can just put it along the entire control line, everything in UAV, and a square foot of this stuff is not even worth a pound. So if you care about range, if you care about payload, this can save you a lot of weight. It's basically a cheap Faraday cage. So here's some statistics we have on tests we've run with it. In this case, we put it against an RF beam, and you can see the attenuation values. It peaks out there about 7 gigahertz, but it's good up to 20 as tested. And you know, we're getting an average of about 50 dB attenuation, which translates to about a factor of 100,000. It's even a million if you get to that 60 dB point. We also stuck it in a waveguide to try lower frequencies. We had some limitations with the waveguide. The signal wouldn't propagate in the red bars there. But again, you can see we're hanging around 60 dB of attenuation, popping up a little over 5. We're currently in a research project to try this below 2 gig down to about 400 megahertz to see how well it propagates there. Obviously, they'll require a bigger sheet. We need a bigger chamber. We're in the process of doing that right now. Another example of graphene is you can use it for lightweight antennas. The antennas can be conformal. We're working on actually printing them within the material of the UAS outer shell. So take a worst case here. Let's say you're using the 900 megahertz ISM band for your first-person video or your command and control because you want to get the longest range. Well, you're going to need like 6 inches of aluminum or copper or something for a halfway dipole. Or you can stick one of these babies on the side of your UAV, be conformal, not have any drag. And so I spent a lot of my time using electro-magnetic modeling software to figure out how this stuff performs against various materials. So in this example, I took a peak OML of a UAS about 14 inches in diameter, a little big, but I was envisioning a long-range fixed-wing UAV. I stick the GNC and the radios and stuff behind it with a conductor, and I want to see what happens. Stick it on the bottom of the UAS, and as you can see in the far corner over there, I'm getting about 7 dBi result, which means I could have an isotropic stub antenna sitting out there causing drag and adding weight, or I could stick this Vorbeck antenna there and get 5 times more gain over an isotropic stub antenna. And you know, keep foot-solving the point, lower weight, lower drag means longer endurance. So one thing we feel very strongly about at Vorbeck is sponsoring the next generation of talent. And Kristen's sitting in the middle here, guy with the red hair, much better looking than me, is doing a project for us. And what Kristen's doing is he wants to see if we can take a link 16 light signal and just relay it 100 miles. So you have an air vehicle over here, you have an air vehicle over here, you can't get line of sight, so you fire this rocket up, the rocket's up there, it releases the parachute slowly comes out, it drags about 15 minutes, and we have an example of his winch in our booth right now, you can see. And so I said, okay, let's stick 4 of our L-band antennas around the body of the rocket, stick the batteries in the SDR, software-defined radio in the middle, and see what happens. And again, we're popping out over 7 dBi. Again, it's a function of the material Kristen used in his rocket body. It's a function of the materials that are in the GNC box, but as you'll see on the booth, it's all real, you know, it's nice heavy metal stuff. And so I did the link budget based on buying a commercially available SDR card that has 20 dB on power. They used our antenna gain. Let's do 50 miles from air vehicle to rocket. Assume the air vehicle has about 4 dBi gain, which is typical. And the receiver requirement's around 100 or minus 100 dBm. And so we close the budget with 3 dBm. And we're actually going to try to do this on a smaller scale, lower altitude, 1 dBm radio. And when that works, we'll expand it up. But we're still going to do it at the higher data rate to prove the concept's correct. Oh yeah, 7K for the whole project. If you want to put the expensive SDR in, it'll be about 25K. I also want to give a shout out to our other interns at Vorbeck. Leah is a chemical engineer. She's done great work in metal corrosion. She's been recognized as one of the top interns in Grand Force this year. And she's also come up with ideas to enhance the ability of fire trucks to perform in situations. Riley is our CAD guy, our additive manufacturing guy. He's built a CAD model of our entire plant that's down the street here. His ability to go from CAD to actual has been a huge value to the company. And he's also built a library of 3D materials to help the company get its plant up to speed. We're also sponsoring a scholarship at UND. It's awarded to College of Engineering and Mines students in electrical engineering, so I can retire and not do this anymore. Hopefully we can get good students to do that. We want somebody who's really strong in Our propagation, for some reason, nobody wants to major in propagation anymore. But that's what we're looking for, and we have 5 years of recipients for this program. So what I want to walk off the stage with is, I hope my talk has shown you that partnerships are a key part of Vorbeck's story. We've gotten to work with some great organizations, and we see a lot of opportunities in the field ahead, especially after what we were hearing this morning from Senator Kramer about where things are headed. And it's been nothing clearer to me that the biggest partnership, after 50 years in dealing with research in one way or the other, is that the best innovation doesn't come from some old guy like me in the lab. It comes from somebody like Kristen in the lab, who comes up with a goofy idea that I'm too dumb to think of, and expands that, and with some mentorship can come up with a product that actually help national defense. We at Vorbeck, you can see with Leah, Riley, Kristen, are investing in the next generation. The second is with the UAS community, and just didn't plan it this way, but I was going to say it anyway, that President Armacost talked about space. Well, yeah, we see a huge market in space, and don't have time to go into it, but there was an article in the Washington Post, I think it was September 20th last year, which was extremely detailed interview and conversations with Chief of Space Operations Saltzman about where we're headed. And my eyeballs kind of popped out of my head when I read some of the stuff in here. I suggest you read it as well. There's a huge opportunity in the future for materials like graphene in space. The third area we like partnership with is federal and state and local governments. We like to use our graphene solutions where they're needed most. And just to walk off the stage is, whether it's in academia, government, our vision is still the same. How can we build these partnerships? How can we enhance products to help UAS in space and deliver impact where it counts? So thanks for your time. See us at booth 407 and see the rocket, see the winch, and we got cool graphene science fair experiments going on there.